All right, well, my name is David. I'm with Fujitsu. I'm here with Larry and Glenn, and we're here to discuss ROADMs this afternoon. Welcome, gentlemen.
Welcome. Thank you.
I know you can't see this on the cameras, but we've got a ROADM here to help us with our discussion. And one of the things I wanted to start off is maybe saying to you, Glenn, where you see ROADMs, or why would you see the need for, as we would summarize, next generation ROADMs, which could encompass colorless, directionless, gridless, contentionless applications, all kinds of things.
Yeah,
yes.
Right. We've got a lot of them out there today, as you would know, right?
Yes.
A lot of them are yours, and we're very happy to get them out there. We've got we're using the ROADMs to deliver wavelength services, and that wavelength services today is carrying primarily our fiber to the home service. It's delivered to every CO that we deliver FiOS out of. So that drove a lot of that demand out there, but now that the ROADM's in place, we're using it for all kinds of other traffic. And that was part of the goal, is to get the wavelength selective switches out there compared to patch panels. You know, they've always been reconfigurable, but it was Joe Technician that was moving to patch panels, and now all of it's built into a really neat little small box. It's a lot of patch cords in there. It's pretty neat.
Well, there's still the concept, though, of the patch panel associated with the add drop. And so where do you see the ROADMs evolving? Is it a form factor reduction, or is it evolving to, you see the need for like colorless and directionless?
Yeah, it's, right now they're still very manual at the access and egress points. Today, if you're on channel 7 and you're on port 7, you're okay. If you want to move to channel 8, you need to physically move that connector. And you need, the transponders are all tunable, and the receivers are broadband, of course, but the wavelength selectable switch is not. I mean, there's an AWG usually, or some way to try and keep you from getting in and out of the switch, only at a particular color or a particular wavelength. And that we have to move. Also directionless. You know, if you want to change from northbound to southbound, again, you got to pull that connector and plug it onto a different WSS. And that's a big issue, because it's anytime somebody touches one of those high-speed connectors, there's an opportunity for error. And we'd like to avoid it. We'd like to automate that.
So the industry standard right now is, at least in the core, is about a 1x9 or 10-port switch. What's your views on where that needs to go next?
I'd happily take double or better. And the reason is, so we don't have so many degrees of freedom out of a CO. A lot of people say, well, why would you need 20 degrees? It isn't necessarily because we got 20 directions coming out of a CO, but it's because we want to bypass a lot of COs. You want to go across the network without any equipment in it, or you want to connect large enterprise customers or perhaps smaller COs than we do today. Now, it doesn't have to necessarily have a ROADM out at that location. It could be a passive WDM, but having a ROADM back in the CO allows us to eliminate that back-to-back transponder. Comes in really helpful when you've got a Bank of America, a very large customer, large data center out there. If you connect them directly to your network by putting a ROADM at the CO with an extra degree running out to their location, now they're a part of the network. They're a part of your network, and they get all the flexibility and reliability and higher availability associated with that.
Another aspect of switches, as we know over the course of the last 5 or 6 years, is the size of these things, and weight, and even power consumption have dropped quite a bit. As these degrees get higher and higher, I guess a question of both, do you see a increased need to reduce the size and power consumption of these units?
Well, we're always interested in power consumption, but I assume that falls back to you for the most part, because you have to build a system around it, and we're looking at it from a lot of cards these aren't the most power-hungry card in the system, but certainly every bit helps.
Yes, we're building systems that, in the past, a system was a ROADM system, and the whole system was based around the ROADM. Now the ROADM is a plug-in card in a system that's doing all types of switching, transponders, multiplexing in there, amplifiers, a lot of different systems. So the power and the space in that system are always a concern, and we're always trying to reduce that.
I would also imagine control or monitoring is also critical as these networks become more sophisticated, understanding from fault isolation perspectives and managing power and other aspects. Is that also something?
Well, we tested these things out to 50 or 60, and I'd be easy to say we're at 3 to 4 times that number that are hooked together today. And the rationale being that you started going into a place like New York City, and you say, well, I'm going to hook up all my primary COs and my video serving offices. Pretty easy to calculate how many you're going to need. Pretty soon that doubles and that triples, quadruples. Now you've got a whole lot of ROADMs connected together, and it's a very analog environment, right? If you've got a fault somewhere, that fault's going to propagate through, or at least the loss of those wavelengths is going to propagate through. You really got to be able to control the power of all those channels associated with it. I mean, that's really critical to make sure that the system remains stable.
So real-time control is critical.
Real-time control and real-time monitoring so that you know what's going on, right?
Yeah, interesting. Some people have talked about self-node identification or wavelength tracking or tagging capability. Do you see that as something that's required in the near future?
Well, I mean, it depends how David sees it, because on our end, of course, it's important that we don't connect the wrong customer to the wrong port. It's fundamental. You can't, that you want to avoid wavelength blocking or wavelength congestion in the network. So how you go about doing that is probably your business. Obviously, to our end, it means I don't want to assign the same wavelength. When we get into this colorless, directionless, contentionless, the system's going to have to be smart enough to tell me no matter how many times I push yes, that it's not going to let me put the same color down the same fiber. And that's something that I think that type of tool would come in useful to you guys at a system level to try and design in.
Correct, yes. It's not only the hardware and the technology and the hardware, then subsequently having the software that'll adjust to all the new functionality of that hardware. If you look at it from a perspective of, in the past, if you had these large electrical cross-connects, which we still do today, and all the capabilities you were doing there, now you're trying to do the same capabilities from an all-optical domain, and then incorporate all the impairments associated with the optical domain, whether they're linear and nonlinear effects and all that, and then subsequently being able to restore the system in the event of any type of fiber cut or any loss of service, being able to reroute the wavelengths all optically. That's also a very big challenge that we're facing.
Yeah, protection and restoration, to use it in a restoration event. That's something that we've always done manually today. Yes. In the event of a long-term outage, what we'll do is we have pre-planned, so we go there and move those patch cords around manually to different directions and different colors. What we'd like to really be able to do is have the network itself do that. Recognize the fact that protection happens in 50 milliseconds, but how long do you want to stay on protection? We had a lot of rain here this past week. If we'd have lost a bridge or something to that nature and lost the fiber, and it's not going to come up in 2 hours, 4 hours, 6 hours. Our mean time to repair numbers, or all our availability numbers, are built around mean time to repair of 4 hours, 6 hours, 8 hours. If it's not going to come up for 4 days or 6 days or maybe 4 weeks, we'd like to be able to restore that optical path, albeit longer and everything else, but we'd like to have the network to be able to do that automatically. And that's where a lot of those extra degrees come into play. That's where a lot of the software control comes into play.
I guess another question is, as the bit rate per wavelength keeps going up, today I would say it's a commodity to see 10 gig wavelengths everywhere, and then 40 gig and 100 gig are also being deployed as well. Beyond that starts posing challenges on the systems being deployed today as far as the spectral efficiency of you having channels that are spaced, for example, at 50 or 100 gigahertz space. As we increase those, do you see the need for architectures that could handle 400 gig wavelengths or 1 terabit? And if so, where? Is it in the access, in the metro, in the short haul, the long haul environments?
Yeah, it's primarily the long haul environment, right? Because that's where the spectral efficiency is the most important. In a medium haul environment, it's always easier to light up another fiber, sometimes even than to add higher bit rates. At least we've seen it. The cost of 10G when you're talking 500 kilometer kind of reaches has come down quite a bit. It's difficult to compete with 40G or say 100G wavelengths at that kind of distances with 10G. And you've usually got more fiber available, and you've usually got more paths available, where it becomes things like 400 gig or terabit in the future. I think where those become really important is on these long haul links where you don't have multiple paths, and you really have to say, well, how am I going to get the best spectral efficiency I can because I've only got 2 fibers that are lit, as opposed to a medium haul environment where today we generally just light up another fiber, and not that 400G or terabit, if indeed it was required for that individual service, could be connected or should be connected, but it isn't something I would see as a network infrastructure kind of build, at least in a medium haul network.
Do you see a shift, taking this up a little bit, to from what we'll call the traditional fixed network needs to the more mobile-driven network needs in terms of traffic that's coming into the network these days?
I mean, mobile means a good radio at the end, right? But as soon as you get beyond that very short distance, it's part of the terrestrial network. Right. So all of that capacity that we're generating today on these mobile devices hits the wired network as soon as possible. You know, it's the radio spectrum is very expensive. It's a precious commodity. What we want to do is offload that traffic as soon as possible, and that means getting fiber out to all the cell sites, or at least as many as we can. We've made commitments as a company to get to 80+%. What we want to do, same thing in your home. You know, you use a wireless connection, but as soon as it picks up a Wi-Fi network, it goes to a wired connection. All of that traffic gets to put onto fiber as soon as possible. So that does drive a whole lot of new capacity onto the wired network that before wasn't there. You know, there's a lot of users out there that are using up what is mobile or what is broadband to the cell phone. But in all honesty, that's as far as you get from the cell tower. Then it's all wired network.
I guess a key question there is all that extra use and bandwidth, is that actually translating into extra revenue, which ends up impacting all of us down the supply chain.
Right. Yeah. I wish revenue would grow as fast as bandwidth demands grow. Unfortunately, that's not necessarily the case. And as you guys know, I mean, because you run a business as well, if revenue's not increasing, CapEx doesn't increase either. I mean, we all have to live in a budget. So that's where we struggle to how are we going to deliver higher and higher capacities without spending a whole lot more money than we do today. You know, that's a pretty level playing field, or level chart. Yeah,
Fujitsu, I think we see it as a constant evolution and not just a revolution. Okay, we've got a new technology, now you're going to pull out everything out of your network and go with this new technology. It's going to be a slow evolution. I remember 10 years ago, people were saying Sonnet was dead, for example, and here we are still deploying Sonnet MSPPs
probably
today.
Sold more Sonnet this year than you did 10 years
Very
ago.
Close, right?
Sure.
Very close.
And it was going to be dead by now, right?
So I think focusing on the ROADMs, it's an evolution, like you said today, 1x9. Maybe the form factor is shrinking, and then as we migrate to colorless and directionless, that's increases the need for more port count or for more WSSs in a smaller form factor, so we can incorporate them into our systems that we deliver to you.
Right. Yeah, and to a certain extent, this, as we have discussed in the past, is really a grooming device, for lack of a better word, to offset a lot of the wavelength traffic so it can be managed more effectively. I would presume that helps in terms of the cost, because now you're offloading some of what you used to do in the routing space and using these types of systems to help groom that traffic.
Well, there's no doubt that, I mean, you've seen the pyramid that we always use, right? Routing is not an option in most cases. Switching when you must, or route when you must, switch when you can, and certainly optical switching is the lowest cost per bit that you can do. Mm-hmm. And that's why, not only the way all the ROADMs are in place today, that's why it proved in so well over the stacked Sonnet rings, was because the ROADM allowed you to do back-to-back, or eliminate those back-to-back transponders as you went from ring to ring to ring to ring. And that's the model that really got us to deploying ROADMs. Now, once they're out there, you can really take advantage of that because you get the same savings no matter what it is. Certainly, if you can move it through, and that's why we look at this colorless, directionless, contentionless, I know it adds additional cost at the access egress node, but if it allows you to reduce the transponder count, reduce the port count on that router, that's all savings that go directly back into the business case.
Another key thing is you mentioned colorless, directionless, contentionless. Is how do you subsequently, one of the things we're always faced with is how do you operationalize that effectively? I think we've done well today, the industry, in operationalizing the use of optical hubbing based around 1x9 WSSs. That we say that's pretty much a mainstay in today's industry. But then going beyond that, as they go to 1x16 or 1x23 or introduce colors and directionless capabilities, how do we operationalize that?
I think that, the way to operationalize that is through automation. You got to have a control plane that allows you to keep folks from making those decisions. They have to be made by the system itself. You know, it really has to be smart enough, to, like I said, not to allow me, no matter how many times I hit yes, saying, no, you've got a congestion problem here. You need to get rid of one wavelength before you can send the save wavelength down that fiber. The system has to have enough intelligence in it to protect us from ourselves, if you will, and it has to be able to optimize itself. You know, we talk about this network defrag kind of application that we would like to see, where once we add a new route, we may have used one of the 1x8s to begin with, and now we've got additional ports and we want to establish new routes. We'd like to move that traffic to take advantage of the new connected route. So now if we connect A to D, instead of going through B and C in order to get to D, we'd rather move all that traffic directly on that direct route. And we'd like the system to be able to do that automatically. I mean, again, we can do this manually. We've done it before, and it only gets done in rare cases when you really got a lot of congestion, because it's a whole lot of work, and there's a lot of opportunity for error. Where here, if the system is doing it, you can step them through one at a time. You can take the traffic, move it in the electrical domain, take the optical wavelength, drop that transponder, tune it to the new wavelength, assign it to the new direction, turn it back on, verify that it's good. Electrical switch can move the traffic back, all done in a hitless environment. Again, not that it couldn't be done today, but there was a whole lot of moving of patch cords and a lot of people that had to get involved in order to do that. Now you can have one person back at surveillance center doing an entire network, and that makes a whole lot of difference. That makes it a whole lot easier to implement. So that's part of that operationalizing it. We believe that things like colorless directionless would allow us to operationalize the ROADMs in a whole lot better fashion than we have in the past, assuming, of course, it comes with all the control plane.
Well, speaking of control plane, are you saying then that everything associated with the control plane would remain at the optical domain, or there would be also an electrical control plane, for example, like an OTN control plane, right, for example?
There is, and the two of them are directly related. I mean, that's part of the goal of putting them into the same platform, is that it would have knowledge of both of those layers and could perform that optimization. Now, today that's even hard to do offline, so I know there's a lot of work to get. We have a long ways to go to get there, but we look at path computational engines that might sit in the center of the network to help with this task, to go through with that optimization algorithm and feed that information back to the network element. Network element may not have knowledge or participate in all of those layers at the same time, but it certainly has the most knowledge of that individual layer. And that's the kind of optimization we want to get between those layers that we see as a long-term objective.
From the standpoint of the industry, do you have any concerns, or are you satisfied with the level of innovation that you're seeing coming down the road?
No, I've been never satisfied with as much innovation as we see, right? There's always more to be done, and the problem is there's just no funding for it, right? You go talk to people who have a lot of bright ideas. We work a lot with universities, we look a lot startups, we work with a lot of smaller companies, and you see good ideas dying on the vine because there just isn't enough money going around right now, and I don't know exactly how to change that. I mean, I know that, in the past, and maybe this is the kind of vertical integration that we might occur, but companies used to spend a whole lot of money on research internally, and they would come up with innovative techniques. Now, granted, a lot of times that was held to one particular company. I got no problem in spreading that out and having that available to multiple companies. That certainly helps us. But it's somehow that research has to occur, and it hasn't over the past years. Everybody's tightening their belt, getting rid of any unnecessary expenses, and unfortunately, research has suffered.
It will all be helped, of course, as we figure out a way as an industry to figure out how to gain more revenue out of the services that are being carried over the communications infrastructure.
By all means,
that would be a good start
means,
to the process.
If the top lines increase of all of our companies, then I'm sure that the spending would increase as well.
Yeah. Are you seeing any other concerns, sticking on that subject, from just the supply chain itself, the number of suppliers?
Well, there's always risk, right? I mean, we've seen some big mergers and acquisitions that today nothing would shock me. How's that? We've seen so many of them that it's partnerships that you wouldn't have imagined have occurred, and that causes a lot of issues downstream.
Well, Larry, speaking of research, and where do you see, or where are you focusing, for example, research on? Is it on getting the form factors smaller? Is it a combination of reducing power or introducing these new technologies that we're going to have to figure out how to operationalize, like we talked about?
Yeah, it is coming from the industry for a while, and we've committed Capella to being on the leading edge of innovation. This product that we've just introduced, the CR, is an example of that. So functional integration, component level integration is part of that key, leading to size, power, cost, and then these new enhanced features that we're talking about, not only port counts, but integrated control. We're trying to do our part to continue that. We've got work underway with the help of Verizon, with Boston University, to take a look at the next generation of technologies that might even further enhance these types of capabilities. We work with companies like Fujitsu and keep in constant contact with them in terms of where your needs are so that we can incorporate those capabilities into these designs. So at the end of the day, this functionality, which was the size of a table a few years ago and is the size of a DVD case, eventually will come down to the size of a photonic chip in its ultimate form, with a lot of control and capability. So it runs the spectrum. So we have a roadmap in place for all the features and capabilities that people have been clamoring for. So hopefully we can keep up with the opportunity that seems to be finally emerging again.
Are you seeing needs or putting out requests for flexible grids or to support, like we mentioned earlier at the beginning of the conversation, these higher bit rates? Or again, I guess that's more focused on the, like you mentioned, the long haul than more the metro.
Today, anyway, we see that as primarily a long haul issue because of spectral efficiency concerns. Now, granted, I mean, it's something that we ought to think about long term in a medium haul network. One of the questions you asked earlier was, how do you see this being integrated? How do you get started on a colorless, directionless, contentionless kind of environment? It's difficult to go say, well, I'm going to take one ROADM out of 20 or 30 or 200 that are out there, and I'm going to place one in the middle. It doesn't do any good. It really doesn't buy you anything. What you look for is, where do I have new deployments that are happening? Maybe I'm building an overlay. Maybe I'm building a new domain in a given metropolitan area. Maybe I'm expanding into another area that I haven't been before. That's where it makes perfect sense to go in with something that you can deploy from day one. So you start with 10 nodes and you grow that to, grow that network in a colorless, directionless, contentionless kind of environment. Because tying it together, it's kind of like the 44 wavelength 4 degree compared to 88 wavelength 8 degree. Now, in more degrees, we can take any time, right? You can plug in another one that's got 10 degrees and it's compatible with one that used to have 4. That's not necessarily an issue because they're at opposite ends. The wavelength count, though, hopefully we're set at 50 gigahertz, and then we can run 88 channels on all the systems that go out there in the future. But if you look at a new environment, a new application, or a new overlay, that's when you can take in the new functionality, incorporate it in all the nodes that you're going to put into that domain, and then you can take advantage of it. It would be difficult to do on introduce it as, say, release 7 on a new product, or release 2, something to that nature, where you only have them spotted in the network. It really is something you got to think about to begin with and implement on a domain basis.
From Fujitsu's perspective, the challenge is not only from the optical domain, but then the electrical domain, getting the wavelength count higher, getting the bit per wavelength higher, operationalizing that, working with the OSS systems that are out there to implement all that stuff that we come out with.
Yeah.
In a fashion that you can use, and then subsequently get all your personnel trained on new technologies. It's in the end result, like you mentioned, maybe it ends up being slower than we all would hope, but it does migrate down.
Right, it's true. I mean, this stuff all takes longer than we expect it to, or that we'd all like it to, right? Especially us as an operator, to try and revolutionize your network isn't easy. But at the same token, if you don't, where are you going to be in 5 years? You won't have made any changes at all. So it happens gradual, but you have to start somewhere. You have to start somewhere. And this transition takes a long time, too. I mean, that's why we looked at this, packet OTP tying together stuff. Why do you need TDM in there? Why even have SONET in it? Well, it's because we don't think SONET's going to go away overnight. Why do you need Ethernet in it? Well, because Ethernet's going to continue to ramp up. Those services are going to become more and more important. Hopefully SONET will decline over time, and wavelength services. But, in the meantime, we've got to live with both of them. And that transition period could be a long period.
Going back to the flexibility, because what we're talking about, at least at the ROADM perspective, is a fully flexible node, any wavelength to any port at any time, for lack of a better word. In that context, another application that we've been playing with is a technology that would allow either add or drop combined into one unit. There have been certain pushbacks for that because of classical east-west separation and failure mode capabilities. Are things like that also?
They have to be taken into consideration, right? I mean, integration is great, but you got to be careful with it. Pretty soon you end up with this little gold brick in the center of the CO, and if it fails, the whole world ends. And that's the part that we're very cognizant of, right? As things get more and more dense, you still have to make sure that you've got somewhat separation so that you don't have a nodal failure. Mm-hmm. Link failures can be tolerated. They can be resolved because links do fail. I mean, a fiber connection has an amplifier, has lots of things on it that can go wrong when you're going across going across city, for instance. But inside the node, as a general rule, that network element isn't considered a single point of failure, or at least it isn't protected from a network point of view, like a link is. And that's the part that you got to be careful about. Now, is a percentage of it, able to fail and still recover? That's why you have working and protect, and that's why you can separate them onto separate cards, for instance, inside of that same box. But would you want everything going through the exact same component? Probably not.
Do you see this type of application starting to show up in the data centers out at the edge of the network?
At the edge of the network, yes, because they're getting really, really large, right? And now the traffic that comes out of the data center is of course very small compared to what happens on the inside of that data center. But yes, the traffic that we do get on the outside has evolved over time. It is continuing to increase.
So if there was one killer feature or need that you wish you had today, what would it be?
On the ROADMs?
Yeah.
Well, I wish all the ones we had out there were colorless, directionless, contentionless, but they're not, So one of our
taken.
Yeah, if they would have been,
Message taken.
Had they had been, we could really take advantage of it right now because we're in a congested issue. We're in a point of congestion. So that's what you look at it. And hindsight's always a lot better than foresight. So we're looking at it going, wow, I wish we'd have paid more attention to that to begin with. Now we can take advantage of it. And what we don't want to do is miss that opportunity, say in a next generation kind of equipment. Again, not the kind of thing that you can go out there and swap out, but it is something that we feel would be important.
Yeah, I think in all fairness, because in essence those questions at the end of the day get directed to us at the basic level, is this technology did need to prove itself in the network, first the 1x4s and now the 1x9. So if I translate your desire, it's really that high port count, fully flexible, small form factor, what we've been talking about today, which is obviously up on deck as technology now has found its way, in a form factor that if it was as big as a bread box, it would probably serve no use anyway. Insertion loss are down, the performance of the systems are up, and again, the power consumption and cost are at a point now where they're easily absorbed.
Right, and you talk about the additional paths or directions. We could use those. We could have used those day one.
Right.
I mean, that's something that we thought 4 degrees. Oh wow, that's so much better than we used to have. Well, then 8. Well, we can barely survive with 8. We're trying to ration those out a little bit at a little bit, saying only the biggest customers. When we told the marketing guys, or the folks who design the networks for customers, well, if you connected a large customer to the network with a ROADM, you'd avoid that back-to-back transponder, reduce the overall cost, improve the reliability, availability. And they said that's a great idea. Then when I started hooking them up, we said, wait. We didn't mean everybody.
Not everybody.
We didn't mean everybody. We only meant the very, very biggest customers. And so if we could do that to more, if we could do that to our large switching centers, MSCs for the wireless switching centers, it'd be an ideal application. But today we just don't have that flexibility yet.
Well, good. I think I don't have any other questions. I really appreciate it's very insightful, Glenn and Larry, talking to y'all. It's very helpful to Fujitsu.
Likewise.
And I appreciate your time.
Well, thank you, David. Thanks,
you.
Larry.
Thanks again.
Thank you.
Looking forward to seeing you again.
Take care.
Okay, thanks.